Hello there. So today we'll be talking about the transport layer. Why do we have the transport layer? How it works? And one of the main parts about how it works is the sockets. What is a socket? We will be discussing that. We will also be discussing about the protocols in the transport layer, namely TCP and a little bit about UDP. So let's get right along with it. So first off, why do we need the transport layer? Well, I think we have discussed before, but the IP protocol in the network layer is unreliable, right? It is also best effort, meaning, sorry, handwriting isn't what it was. Best effort, meaning it drops packets when it doesn't have enough space. And it is connectionless, meaning there is no connection between each different frame, right? So the transport layer solves most of that problem. It makes a reliable connection. It, accounts for lost packets, right? And after accounting, it asks for retransmission at times so that, even if something is lost, it can, be gained back. And one of the more important reasons why we need the transport layer is simple. So let's say I have a computer here, right? And it has an IP address. Then let's say that there's a server here, right? So it also has, let's say, an IP address. Sure, you can connect these two, but let's say the computer has more than one application running. So how can you differentiate between different applications using a singular IP address? You can't. So that is where the transport layer comes in. So as you all know, first there's the application layer, and then there's the transport layer, right? So the transport layer, the correct definition for the transport layer is it provides a logical communication, logical communication between client and server, okay, for running, remember it has to be running, application processes on different hosts, right? So I believe on different hosts and client and server is the same thing, and I have written on different hosts without client and server, but again, it's best that you have include more keywords in the actual definition, right? So we talked about why we need the transport layer, but now let's talk about how it works. So as you can see here, I have written the application layer and the transport layer, and we will talk about the socket a little bit later. In fact, I believe we should talk about the socket right now. Hell, it's my channel, I can do whatever the fuck I want. So, what is a socket? Well, a socket is something that each application has. It's an endpoint communication. It is used for endpoint communication, right? And essentially, it is unique for every single application. So, let's say there's 3 different applications running at the same time, right? So you may have Chrome, you may have Netflix, and hey, let's say for some weird reason you got Firefox as well, right? Maybe you're downloading something using Firefox and you're watching something on Chrome. Anyways, so how do you identify each of these different applications? Well, you use something known as port numbers. right? Each of these specific applications have their own port numbers. So I'm going to give this 1, 2, 3. I'm going to give this 4, 5, 6. I'm going to give this 7, 8, 9, right? So what the transport layer, this, happens in the transport layer is essentially all of these are combined to a singular data stream, right? So this is what will be included in the header of the transport layer, right? So as you all know, the application gives the message. So along with the transport layer header, you make it into a segment, right? So this is the job of the transport layer, combining the port numbers into a singular data stream so that you can uh, include it in a singular segment or whatever happens there. So this process, what is this process called? Well, if it is combining, it's called multiplexing. Now, this is on the client or transmitter side. Well, actually, let's say this client is transmitting at this certain point. You will realize why I'm talking client instead of transmitter. It's a new term, but patience. Anyways, so let's say that the transmitter here is combining all of this. Well, it's multiplexing. And so then the receiver, he will have to extract the data from the segment, right? He has to remove the separate what port numbers, and the server has to know which port number and so on and so forth. So that process is known as, I think you must have already guessed it, demultiplexing. So what is the official definition for multiplexing and demultiplexing? It is simply, want to write multiplexing slash demultiplexing. It is the process of either combining, that is multiplexing, but when it comes to demultiplexing, it's extracting data. So if it's combining, it is combining it into segments, right? Or if it's extracting, it is extracting from segments data such as port numbers, uh, transport header, uh, pardon me for writing header transport, header transport, uh, and I'm going to say etc. just in case, right? So this is what multiplexing and demultiplexing is. Simply the process of combining or extracting data into segments or from segments, data such as port numbers, header transport, etc. Right? So what is the use of a socket? What does a socket do here? Well, socket is unique for each running application, right? Is unique for each running application. And as I said before, it acts as an endpoint communication, right? So it's unique for every single application. And as you, for instance, to give you an example, Chrome can have more than one socket, right? For different websites to do different things, right? Uh, Again, it can be unique for every single application, but it doesn't mean an application can only have one singular socket. Okay, so now let's talk about TCP, Transmission Control Protocol. So why do we use the TCP? Well, it is very reliable, right? It is reliable. It is also in charge of congestion control, right? It is in charge of congestion control. It is in charge of flow control. It is also in charge of connection setup, right? So what is congestion control? Well, mainly traffic. If something is, let's say, the buffer is full, then basically it has to know all this information to give a reliable connection, right? Flow must also be smooth. For instance, let's say that the buffer is full or near to full, then I should be like, okay, let's send new data a bit more slower, so until the load is reduced. And connection setup is very important, and we will talk about this. But we keep talking about reliable, reliable, reliable. What is reliability? Well, there are two ways when it comes to, reliability, two main points, actually, not specifically reliable. One is abstraction, right? And another one is implementation. So let's say that there is an unreliable channel, right? An unreliable channel. So if the layer assumes, very important point, assumes that this layer is reliable and then sends data, it is an abstraction, right? It is not, real. It's an abstract concept or something like that. So this is abstraction, where sending data, assuming that the underlying channel, the term for this is an underlying channel, is reliable, assuming its underlying channel is reliable and sends data through it. This is what's known as abstraction. But there's something called implementation. The layer takes extra steps to make the underlying channel reliable, right? To make the underlying channel reliable. So this is implementation, where it goes through that extra effort and goes like, oh, okay, so this has to be safe. This has to be this thing, so on and so forth. So this is what usually UDP does, User Datagram Protocol, whereas implementation is basically TCP. It doesn't care about, whether the stuff happens or not. This is mainly focusing on speed, where this is mainly focusing on reliability. So let's talk about how TCP implements. So to implement, it has three main steps, right? So first things first, connection establishment, data transfer, and connection termination, right? So let's talk about all three, the implementation of TCP. So there are two main people here, client and server. Client, server, client, server. So the communication happens between both of them. So when it comes to establishment, first the client sends something which is known as an initial sequence number, right? And the server sends an acknowledgement. We will talk about the numbering a bit later. We will talk about the numbering by combining all of them together, right? So for now, just understand the concept. When it comes to establishment, the client sends an initial sequence number, and the server sends an acknowledgement. Then the server sends an initial sequence number and gets an acknowledgement. So what is the initial sequence number? Well, it's known as a synchronization flag. It is a singular byte, and it is a singular byte, right? Then the data transfer, where client sends something with a sequence number and the data, server sends an acknowledgement, then server sends again data with its sequence number, and client sends an acknowledgement. So this can happen in any way you want. It doesn't have to happen at the same at different times. It can happen parallelly as well. So what is acknowledgement number? We will talk about it in a while. And termination. So client sends a final finished message or fin. Server sends an acknowledgement. Server sends a fin, and client sends an acknowledgement. Now, if you are a good computer person or a programmer, you may notice, hey, isn't this a bit redundant? Sending everything in different, messages. Why can't we shrink this thing? So for now, this is known as a four-way handshake, and this is data transfer, right? But we can do something that is very important, which is send the initial sequence number with the acknowledgement, right? Or send the, yeah. So this shrinking of the process is known as a three-way handshake, right? And similarly, when it comes to data transfer, we can send the data with its sequence number and the acknowledgement. And this is known as piggybacking. And now you might be like, hey, Yazim, what if we can combine these two as well? But when it comes to termination, we want termination to be as precise and clear as possible, right? Hence, we do not shrink it in any way whatsoever, right? So how does this all work together? Let's find out. So I'm going to be drawing something here. So this is the client. This is the server. So let's look at a quick example. So they should always give you this, right? So they should say the client ISN is equal to 6,000. Okay. Server ISN is equal to 2,000, right? So here's the data that the client and server have to share with each other. So first 200 bytes, then 100 bytes from client to server, then 200 bytes from server to client, 250 bytes from server to client, and last but not least, a little eeny miny 10 bytes back over to the server, right? So how does this happen? Well, first up, we have to do is synchronization, right? The synchronization flag, which is equal to 1 byte. The synchronization flag is equal to 1 byte. Fin flag is also equal to 1 byte. Synchronization plus acknowledgement is equal to 1 byte. Essentially, it means that acknowledgement flag is equal to 0, right? And fin plus acknowledgement flag is also equal to 1 byte, and acknowledgement flag is 0 bytes, right? We should know this data to basically do this. So client ISN is 6,000. So client sends an ISN equal to 6,000. It sends a synchronization flag. Now remember, it is equal to 1 byte. Then server sends with an ISN of 2,000, right? Now it sends an acknowledgement. So what is the acknowledgement number? It's actually AN, acknowledgement number. some of you might be like, okay, so 6,000, right? So 6,000, this is the first number, right? This is the first number. You will understand as I go down and explain the data bytes here. But the 6,000th data has been sent, and the acknowledgement number is saying, okay, I'm expecting the next one, which is the 6,001st data. So it'll be like, hey, I'm expecting the 6,001 data. And here, it's going to send a synchronization plus acknowledgement. So the synchronization data, I believe, is 2000. The acknowledgement number is 6001, right? So now, again, the client has to send an acknowledgement of SN. It's not initial sequence number, it is the sequence number of how much? 6001, right? So it sends the 6001st one, right? The sequence number, and it has to send an acknowledgement number of 2001, right? I hope you understood this. Let's move on. I hope you'll get a little bit more understanding when you do bytes data transfer. So now the acknowledgements three-way handshake is now complete. Now the data transfer has to be done. So as we discussed here, acknowledgement flag is 0 bytes. So again, it will send of sequence number 6001, right? It will send the 200 bytes, right? And again, it will send the acknowledgement number of 2001. It's almost as if this didn't happen. Now, I believe you can conjoin both of this, but it's best that you separate them and do it as different systems, right? Right. So now it has sent the 200 bytes. Okay. But instead of this, you getting an acknowledgement and sending 100 acknowledgement and then sending 200, you can instantaneously send the 200 from the server side to the client, which is also 200 bytes. So again, the sequence number here must be this number, 2001. Acknowledgement number should be equal to 6001 plus 200 minus 1, right? So if I add, it's going to give 6200, right? So up to 6200 it has received. So then it should be like, okay, I have received up to 6200. I am expecting the 6201st data, right? Okay, so now we have also done this one. Now let's move on to the 100 bytes. I'm going to make this a bit more neat. Right. So now these two are done. So now the client sends to the server 100 bytes. What is the sequence number? The sequence number must be the acknowledgement number, 6201. But it should send an acknowledgement number for this. So it should be like, okay, I received up to 6200. So 6200. I'm expecting your 6201st data. Now, why is this? Why shouldn't it be 6202? Well, let's say that there is a sequence number starting from 0 and I'm sending 10 bytes. It should actually be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? 9. And then it will be the next one that it should say, the acknowledgement number is saying, I am expecting, the acknowledgement number is saying, hey, I'm expecting this value. And the next sequence number will start at that value, right? So this is how it works. So it has set the 100 bytes, correct? So now it has to send the sequence number of 2201. It will send its 250 bytes, right? And it will be like sequence number 201. Well, you're going to add 99. You're going to get 6300. And acknowledgement number is going to be 6301. Right? It's going to be like, hey, okay, I have received up to 6300. Now send me 6300 at first data. So now we've taken care of this. And finally, the client is going to send the 10 bytes. Right? It's going to have a sequence number of 6301. It's going to have an acknowledgement number of, well, add 250 to this. So I'm going to add 250 to this, and you're going to be like 2, 2, oh, it's not 2, 2, it's 2, 4, 5, 1, right? And finally, that's all the data that's going to send. So finally, it's only going to send an acknowledgement, right? There's nothing else, of sequence number 2451 with an acknowledgement number of 10. So 2461, right? I hope you understood. And there's nothing else. Acknowledgement number is 0. So along with that, finally, the connection termination should happen. Now, connection termination, as I said, there is no shortening when it comes to connection termination. You have to properly end a conversation, right? I haven't learned how to do this in real life, but at least I have solace that I know how to do it in a TCP handshake. Anyways, the sequence number here is going to be 2461. It's going to send a fin flag. It's also going to send the acknowledgement number for 2451, because again, it didn't receive anything from this. Acknowledgement is 0, right? So it's going to send the same acknowledgement number here, right? And then it's going to send the sequence number of 2451, an acknowledgement flag, right? And it's going to send its acknowledgement number. Remember, fin is 1 byte. So if it's a 1 byte, then it's going to be saying, hey, I'm expecting the 2462. I'm expecting this one. Now it's again going to send a fin1, fin data packet or something of, I believe, 2451, acknowledged number of 2462, and it's going to get an acknowledgement of sequence number 2462 and acknowledgement number. Okay, since this is a singular byte, and that singular byte is the 2451st number, it's going to be like, okay, I received that. Now I'm expecting this. So this is how TCP communicates with each other. I'm gonna try to shrink it as much as I can. So as you can see, there's a lot of connections here. I hope you understood all that I'm saying here. So I will be uploading a specific other video talking about how to decode an IP frame and a TCP segment. I will be talking about how to decode them. So essentially, there are a bunch of numbers. So TCP port numbers and all that stuff. I will be uploading it later in another specific video. But what I did forget to upload in it, because I had already recorded it, is that there are some specific TCP numbers with some specific values, and there are some specific UDP numbers with some specific values, right? So each of these ports are important. So there are something known as well-known ports, which is reserved actually. So 0 to 1023. There's so a few examples for that is TCP 80 stands for HTTP. TCP 443 stands for HTTPS. TCP 25 stands for SMTP, Simple Mail Transfer Protocol 25. TCP 53 stands for DNS. TCP 22 stands for SSH. Uh, and also when it comes to UDP, there's a few. So UDP 53 stands for DNS. UDP 67 or 6867, baby. Okay, I'm fucking brain rotted. Both of these stands for DHCP, Dynamic Host Configuration Protocol. 123 stands for NTP, and UDP 161 stands for SNMP. So that's one very important thing. How do you know whether whether it's TCP or UDP? Well, that is included in the thing when it included in the header in the IP frame known as protocol, right? So if the protocol number is 6, it's a TCP protocol. If the protocol is 17, it's UDP. If it is 1 or 2, it is ICMP. And yeah, so this is it. Now you may be wondering, what about ARP? Well, ARP is included in the Ethernet frame, right? In the Ethernet frame. So as you all know, the Ethernet frame has something like this. So there's something of a preamble. The first thing is a preamble. And then there is the destination MAC address. Then there is the source MAC address. And then there's the type, right? So I think we have learned before. So you can include stuff like 8021Q, that's the encapsulation for VLANs, encapsulation thing, where this is in the between trunks, right? So here there is the, I believe, uh, tag control info, and I believe there's another thing, I forgot what it is, but anyways, here will be include, it may be either ARP or something. So here is where you will have the type, right? And finally you have the data or payload. Then finally you have the error checksum. So usually it's CRC, usually CRC. Oh, this is basically the error checksum, right? So this is for Ethernet protocol, right? Ethernet protocol happens down where? Down, way down in the link layer, right? So this happens at the link layer. So this is where ARP is located. This is where ARP will be located. So it doesn't have anything to do here. So it's not in the IP frame, right? I want you to remember that before you go to the other video. Anyways, finals are basically tomorrow and the days after. Anyone who's watching this, I wish you the best of luck. And one more thing that's very important that I must say is, remember you are loved, remember you are cared for, remember you are important. You may have go through hardships, you may go through pain, but all of that is important for character development, because if everything goes well or everything goes badly, there's nothing, nobody's going to read that story, nobody's going to watch that story. Every single story has ups, every single story has downs. There may be more downs than ups, yes, I agree with that, but at the end of the day, you are important and you are loved. No matter what marks you get, no matter what, it may be bad, it may be good. If it is good, celebrate it, but if it's bad, don't lose your life over it, don't lose your mental peace over it. Cherish the moments that you have, and remember there are people who love you. And even if everything seems bad, even if there is everything dark, remember there's always light at the end of the tunnel. And I hope you all have a great day. Good luck for your finals and best of luck. Thank you very much.